Hey everyone, and welcome back to another video. Today we're going to be solving the LeetCode question, sum of square numbers. In this question, we're given a non-negative integer c, and our goal is to decide if there are two integers a and b such that a squared plus b squared is equal to c. So a quick example is when c is equal to 5. In this case, a could be 1 and b could be 2. And when you square them, you have 1 squared plus 2 squared, which is 1 plus 4, which is equal to 5. In that case, a squared plus b squared does equal c, so we return true. But now with the number 3, for example, there's no combination of numbers which is going to give us the value 3. So for example, let's take 1 and 1. Then we will get 2, right? Which is too small. Now let's take 2 and 2, which is 4. And any other number we add is going to be greater than or equal to 4. So it doesn't really matter. So let's see how we can solve this question step by step. Let's start off with an example of c being equal to 5. So we're taking c to be equal to 5, and what we're going to do in the beginning is to use our most naive solution. So our goal is to find a and b, and if they exist, we square them and add them, and they should be equal to c. If this is the case, then we return true, and if not, we return false. So our goal is to look for a and b. But realistically, how are we going to do this? So in other words, what is the search space going to be? So it tells us that a and b are integers. So we could have everything from negative infinity all the way to positive infinity. But one thing we can directly get rid of is all of the negative numbers, because remember, we're squaring these values. So for example, negative 10 squared is the same thing as positive 10 squared, which is equal to 100. So since we got rid of these negatives, we don't need to worry about any negative values. So then the range would just be 0 to positive infinity. Okay, so but now we can make it a lot easier for us. So instead of infinity, let's go to, let's say, 100. Okay, it's 100. But in this case, c is equal to 5. There's no reason to go to a value greater than 5, because look, if you take the value 5 itself, 5 squared is equal to 25. That's too big. So in this case, we could stop our search space up to the value of c itself. So our search space could be, instead of 0 to 100, we could do 0 to the value of c. So, let's see what this looks like. This obviously simplifies it further, but let me just show you what we can do. So let's say we have, because c is equal to 5, we have 0, 1, 2, 3, 4, and 5, right? Now, what we could do is we could have two for loops like this. We have 0 and 1, 1 and 2, 2 and 3, and then we have a second for loop right here. Oops, let me make that better. Okay, so we have these two for loops, and they're going to iterate through all the possible pairs. Each time, we're going to check after squaring them and adding them if it's equal to 1 to c. If at any point they're equal to c, we return true. So this over here is going to be big O of n squared. And this is going to be our brute force solution. But the problem with this is the values of c could go all the way up to the value of 2 to the power of 31. That's almost 2 billion values. Obviously, this is not a very good approach. So let's see how we can make the search space even smaller. So let's say, for example, c is equal to 25, okay? The first thing that comes to your mind is that 5 squared equals 25, right? So now in this case, we could do a is equal to 5. So that would mean b is equal to 0. What I'm showing here is that there is never going to be a number greater than 5, which will help us satisfy its condition of a squared plus b squared equals c. The reasoning is pretty simple, because if 5 squared equals 25, 6 squared, 7 squared, or whatever, anything past that is always going to be greater than 25 no matter what. This is one way we can further shorten our search space. Instead of going from 0 to c, we can just go from 0 to the value of the square root of c. So instead of equal to 25, we could go from 0 to the square root of 25, which is 0 to 5. Okay? So in this case of c being equal to 5, what is the square root of 5? So it's going to be 2 point something. So we can just say it's 0 to the value 2. We can round down. So now we only have to deal with 0, 1, and 2. Okay? So this over is going to be our new search space. Now we can run 2 for loops and look at the combinations. Obviously we have fewer pairings, but still, remember, C can be up to all the way to 2 to the power of 31. So we want to further simplify it. Instead of having 2 for loops and looking at every possible pair, we can use a simple 2-pointer approach. So we're going to use a low pointer, L, or L for left, and we're going to use a high pointer, or R for right, at the very ending. The basic idea is that each time we're going to calculate the value. So currently we have 0 squared plus 2 squared, which is equal to 0 plus 4, which is equal to 4. Now, obviously, 4 is less than 5, which is what we want. So, the goal is to look for larger values. We can do this by moving the left pointer to the right by 1, from 0 to 1, because the values on the right are greater. If the values are too big, we move the right pointer to the left by 1. We keep doing this until we find the solution. And then if we find the solution, we return true. If we don't find a solution at any point, the right point is less than or equal to the left point, then we break out of it and return false. So since the left pointer was right here, what we could do is we can move the left pointer all the way 1 right. So this would be our left pointer. So now we have 1 squared. Let me change the color. So now we have 1 squared plus 2 squared, which is equal to 1 plus 4, which is equal to 5. And 5 is equal to 5, which was our value of c. So perfect. Now we reach the value c and we return true. This is going to be our search space. 0 to the value of radical c. And then on top of that, we're going to use a simple 2-pointer method. So now let's start coding. So we can start by implementing our 2-pointer system. So we'll have our left pointer and our right pointer. And we can set our left pointer, as we said, the range is going to be from 0 to the square root of c. So our left pointer is going to be 0, and our right pointer is going to be the integer of math dot square root of c. So math dot square root of c. And let's just import math. So we're just setting the left pointer to 0 and the right pointer to the square root of c rounded down. Okay, so now let's create our while loop. So we'll say while the left pointer is less than or equal to the right pointer, a squared is just the left pointer times the left pointer, and b squared is just the right pointer times the right pointer. So if a squared plus b squared is equal to c, then we return true. But if a squared plus b squared is less than equal to c, so remember we said when the value is less, we're going to increment the left pointer by 1 to get a greater value. So we'll do left plus equals 1. Then the other case is if a squared plus b squared is greater than or equal to c, so the value is greater than what we're looking for, we can take the right pointer and we can decrement it by 1. And let's say eventually our left pointer becomes larger than our r, what we could do is we could return false. So now let's submit this code. And as we see, it works. So I hope this tutorial helped you out, and thank you so much for watching. Have a good day.